Hello, my dear students. This is our lecture number 23, and the topic is numerical problem on thin cylinder part 3. So, this is our unit 1 in mechanics of solids, and our subject code is 1625303. My name is Sudhir Kumar, a lecturer in mechanical engineering from James Polytechnic College, Aurangabad, Bihar. So, today we are going to see one more problem on the topic thin cylinder. So, let's see the problem. So our question says like this: a water main 80 centimeter diameter a water main 80 centimeter diameter contains water at a pressure head of contains water at a pressure head of at a pressure head of 100 meter. If the weight density of water is if the weight density of water is 9810 Newton per meter cube. Find the thickness of the metal required for the water main. For the water main. Understand? The permissible stress is given as permissible stress value as 20 Newton per millimeter. 20 Newton per millimeter. So this is our question. Once again I will repeat the question. A water main 80 centimeter diameter contain water at a pressure head of 100 meter. If the weight density of water is 9810 Newton per meter cube, find the thickness of total required find the thickness of the metal required for the water main. Understand? And the permissible stress value is 20 Newton per millimeter square. This is our question. एक बार हिंदी में बोल देते क्वेश्चन कुछ इस प्रकार से बोलता है एक वाटर मेन है जो कि 80 सेंटीमीटर डायमीटर दिया गया है उसके जो प्रेशर जो वाटर हेड का है वो मतलब कि जो प्रेशर हेड है जो वाटर का उसका मेन का वो 100 मीटर का है और उसका जो वेट डेंसिटी दिया हुआ है कितना 9810 न्यूटन पर मीटर क्यूब हमको क्या फाइंड करना थिकनेस फाइंड करना है समझ में आ गया और परमिसिबल स्ट्रेस का वैल्यू 20 न्यूटन पर मिलीमीटर दिया गया है सो व्हाट वी विल डू एज विजुअल एज वी आर डूइंग ऑलवेज फर्स्ट वी विल राइट आवर गिवन डेटा द फर्स्ट स्टेप व्हाट वी विल डू फर्स्ट वी विल राइट आवर गिवन डेटा What are the given data are given? Yeah, diameter of main. That means D. The value of D is given as 80 centimeter. Okay. Pressure head of water. H is given. How much? 100 meter. Then weight density is given. How much? 9810 Newton per meter cube. Then permissible stress is given. How much? 20 Newton per millimeter square. 20 Newton per millimeter square. And one more thing we know that, what we know that permissible stress is only circumferential stress. Understand? So circumferential stress value is also given in our question, because permissible stress value is only the equal to the circumferential stress, because चूंकि permissible stress equal to circumferential stress, so that circumferential stress will be equal to how much? So circumferential value will be also equal to 20 Newton per millimeter square. Understand? Please keep in your mind. This thing is very important. So we know that the circumferential stress value also. Now let's do our solution. So now we will do our solution. Actually, what we have to find? We have to find the thickness of the metal required. Understand? So for that, first of all, what we have to find? Pressure of water inside the water main we have to find. Pressure of water inside the water main. So we know the formula. P is equal to rho into G into H. Rho into G into H. This is the formula. Understand? Or instead of rho G, what we can write? W into H. Or instead of rho G, what we can write? W into H. Understand? So we know the W value. How much? Weight per 9810. Understand? Weight density of water we know na, 9810 weight density. And then what is the height? What is the height value? Height is 100. So we got as 9810 into 100 Newton per meter square. Okay, this is the value for P. Then what we have to find here? Actually, if you will be circumferential stress in Newton per millimeter square, hence the pressure P should also be in Newton per millimeter square. So the value of P in Newton per millimeter square is given as, so we will write first चूंकि hence sigma C is in Newton per millimeter square. Okay, hence pressure P should also be Newton per millimeter square. So the value of P in Newton per millimeter square is P equal to 9810 into 100 divided by 1000 square. Okay, now we got as 0.981 Newton per millimeter square. This part was very important because all two values should be in same unit, na? That's why we got finally the value of pressure in Newton per millimeter square. So we got as P equal to 0.981 Newton per millimeter square. Why? Because 1 meter is equal to 1000 millimeter. These things you know, na? So we have to convert into millimeter square. That's why we have a squared here. That's why we have a squared here, 1000 squared here. Understand? Actually, that's why we have C. Actually, I have written here clearly. Hence C. Circumferential stress in Newton per millimeter square, and hence the pressure should be also in Newton per millimeter square. That's why I have changed the unit. Here the pressure unit is Newton per meter square. So I have changed the unit. I converted Newton per meter square into Newton per millimeter square. Understand? Now we will solve our problem. Means what we have to find, we will directly solve those things. So now what we have to do, we have to find the thickness. We have to find thickness. That means T, the value of T we have to find. Understand? So already we know the formula. Which formula? Circumferential stress. So, oh sorry, we know that circumferential stress, that means sigma C. What is the formula? P into D divided by 2 into T. We know this formula, na? This is our main formula. Understand, my dear students? So this formula we will use everywhere in problem of thin cylinder. So you have to remember this formula. So already we know that. Which one we know that? Sigma C, circumferential stress, is equal to P into D divided by 2 into T. But what we have to find, actually from this equation we have to find the value of T, and we know all other data such as we know the value of circumferential stress, we know the value of diameter, we know the value of pressure. So finally what we have to find, we have to find the thickness. So if we will convert this equation into our equation which we have to find, then our T will be equal to P into D divided by 2 into sigma C. This will be our new formula. Understand, my dear students? This will be our new formula. T is equal to P into D divided by 2 into sigma c. Understand? So now what we have to do, we have to put all the data here. What is P here? What is P here? Here P is the pressure of water inside the water main. Understand? P is the pressure of water inside the water main. What is D here? D is the diameter of the main. And what is sigma C? Sigma C is circumferential stress. And what is T? T is the thickness of the what? Water main. So finally what we have to find, actually according to our question says find the thickness of the metal required for the water main. Actually we have to find the thickness, understand? That's why we have converted our formula according to our need. See, actually original formula is this one. This one is original formula. Sigma C is equal to P into D divided by 2T. But according to our need, actually we have to find the thickness. That's why we have converted this formula according to our use. So our formula becomes like this: T is equal to P into D divided by 2 into sigma C. Now what we will do, we will put all the data in our formula. So now we are going to put, so 0.981 into 80 divided by 2 into 20. So we got the value of T as 2 centimeter. Understand? So we got the value of T as 2 centimeter. So the thickness of the metal required for water main, so the thickness of metal required for water main is equal to how much? It is equal to 2 centimeter. Understand my dear students? So this is our solution. So finally we got our answer. एक बार फिर से आपको हिंदी में बता देते हैं हम लोगों को क्या करना था। हम लोगों को सब चीज दिया गया था, हमको केवल थिकनेस निकालना था। किस फार्मूला को यूज करके? सर्कमफ्रेंशियल स्ट्रेस फार्मूला को यूज करके। हम लोगों ने क्या किया, फार्मूला को अपने अनुसार हम लोग रिकंस्ट्रक्ट कर लिया। क्योंकि देखिए ये जो हमारा फार्मूला मेन है इसी के अनुसार हमको थिकनेस फाइंड करना, तो टी को हम लोगों ने इस साइड कर लिया और सिग्मा सी को इस साइड भेज दिया। अकॉर्डिंग टू हमारा जरूरत के अनुसार फार्मूला को रिकंस्ट्रक्ट कर लिया। और फाइनली हम लोगों ने सब वैल्यू तो जानते थे, पी का वैल्यू जानते थे, डी का वैल्यू जानते थे, सिग्मा सी का वैल्यू जानते थे। तो फाइनली हम लोगों ने टी का वैल्यू जो कि थिकनेस दर्शाता है उसको फाइंड किया। कितना आया? 2 सेंटीमीटर। मुझे विश्वास है आपको ये प्रॉब्लम समझ में आ गया होगा। धन्यवाद। So, if you want to gather more knowledge about the particular numerical problem, then you can refer these two books. The first book which I will prefer is Strength of Material by Dr. R.K. Bansal, Dhanpat Rai and Sun Publication, and the second book which I used to prefer is Mechanics of Solid by R.S. Khurmi, Sun Publication. If you will refer these two books, then you can get a clear concept about the numerical problem, especially about the thin cylinder. So I hope you all must have got a clear concept about the particular topic and you must be able to solve all the numerical problem regarding thin cylinder. Thank you.